Welcome to online stats class. Today's section is section 7.1, Introduction to Hypothesis Testing. Let's go ahead and take a look at the objectives for today. All right, this is not working. Let's see. All right, there you go. Section 7.1, Objectives. We will look at what does it mean by hypothesis test. We will look at how to write a null hypothesis and an alternative hypothesis. At the same time, what do they mean? We will identify different errors, which are type 1 and type 2 errors. You will look at different kinds of tests in your hypothesis testing. You will also learn how to interpret the decision and write a claim for a hypothesis test. Before I start this, I want to mention, please make sure you have your pen and paper ready because it's very important you write down the important stuff that we're going to talk about today. All right, what is a hypothesis test? So all that you studied from chapter 1, 2, 3, 4, 5, 6, you will put to use in chapter 7, which is your hypothesis testing. So let me go ahead and look at the example here or show you the example, and then we're going to work our way backward. Consider a manufacturer that advertises its new hybrid car has a mean gas mileage of 50 miles per gallon. If you suspect that the mean mileage is not 50 miles per gallon, how could you show the advertisement is false? So pause for a second and see what's happening in this example. So this random car manufacturer, let's say the name of the car is Kahuna. Okay, the Kahuna is the new manufacturer of the cars, and they claim that their hybrid cars are 50 miles per gallon. And now you as a statistician, you either prove them or disprove them. What do? You technically cannot drive every car that's the population, right? You cannot. It's impossible. What do? You take a sample. Exactly. You take a sample and then you get the mileage of each and every car from the sample. Remember, your sample has to be greater than 30. So you take a sample of 45 and you drive every car and you write down the mileage and you get the average mileage. That is your sample statistic. So based on your sample statistic, you will infer about your population. That's exactly what your hypothesis testing is. It's a process that uses sample statistic to test a claim about the population parameter. Now we know what hypothesis test is. Let's go ahead and see how do we even start doing something like that. First step is to state your statistical hypothesis. What does it mean, hypothesis? We use the word hypothetically, or, according the hypothesis is. So let's see what that means. It's a statement about a population parameter. If I go back to the example, what did the manufacturer claim? He said, hey guys, my new hybrid car gives you mileage 50 miles and more of mileage. Let's see what he said. He said, has a car mileage of 50 miles per gallon. That's what he claims, right? So he claims his car has 50 miles per gallon. So that's the claim that so that's the statement about population parameter that the manufacturer made. So what you as a statistician, what you do is you carefully state a pair of hypotheses. So in your hypothesis testing, the most important step is to state the pair of hypotheses. So let's go ahead and see what they are. One represents the claim and the other represents its complement. So they are opposite to one another. When one hypothesis is false, the other hypothesis is true. Okay? The names of the hypothesis are, it's called null hypothesis and alternative hypothesis. Null hypothesis, let me pause. So a null hypothesis is represented by H and a 0. That's called H naught. Okay? That it is a statistical hypothesis that contains equal to sign. You see, less than or equal to, simply equal to, greater than or equal to. So technically, null hypothesis is nothing but something that has an equal to sign. Keep that in mind. If you say it's a null hypothesis, it has to have an equal to sign. That is greater than or equal to, less than or equal to, or simply equal to. Please write this down. Now let's look at alternative hypothesis. An alternative hypothesis is a complement, that is, they are opposites of one another. So the alternative hypothesis is simply a complement of your null hypothesis. So it is a statement that must be true if null hypothesis is false. So technically, if null hypothesis is true, your alternative hypothesis is false. If your null hypothesis is false, your alternative hypothesis is true. Okay, and the way you write them down is when you look at your inequalities, do you see that this only has a greater than, it does not have equal to? This is not equal to, and this is less than. So if this is greater than or equal to, the opposite is less than. If this is equal to, the opposite is not equal to. If this is greater than, the opposite is less than. Okay, so let's look at the symbol H naught is read as H sub 0 or H NaUGHD, and HA is H sub A. Okay, so it's H naught and HA, ho ha, some of them call it like that. Stating a hypothesis, to write the null and alternative hypothesis, translate the claim made about population parameter from a verbal statement to mathematical statement. This will make much more sense when we start to do an example. So what I want you all to see right now is this is your null hypothesis, H naught. So let me go ahead and pick here an arrow. So your H naught is your null hypothesis. Your HA is your alternative hypothesis. Look what's happening. The symbol is less than or equal to. What is the opposite of less than or equal to? It is simply greater than. Do you see that? Okay, one thing you'll have to keep in mind is the null hypothesis always has equal to. The alternative does not have equal to. If it has equal to, it cannot be an alternative. So only the null should have the equal to sign. Now let's go ahead and look at the next one. So let me go ahead and put everything here so y'all can see. Okay. Null, H naught, HA. What is the symbol here? See, greater than or equal to. Do you see that? It or equal to. And the alternative is simply less than. They're opposites. So opposite of equal to is not equal to. So you technically see that your alternative here is simply greater than, yet this is less than or not equal to. Whereas your null hypothesis is greater than or equal to, less than or equal to, greater than or equal to, or simply equal to. So it's very important you all know that your null hypothesis should have an equal to sign. Okay, so let me go ahead and click on the next one. So regardless of which pair of hypotheses you use, you always assume mu is equal to k and examine the sampling distribution on the basis of your assumption. What that means, I will tell you once we move on with the next one. Okay, so let's go ahead. What I want you to do right now is let's go ahead and open up your homeworks. Go ahead and take a look at section 7.1 homework. A couple of problems are taken away because they're not needed. We're going to start with problem A. Just like in class, I will be going back and forth with different kinds of problems here. So the first problem here is problem number 8. I'm assuming you're also on problem number 8. So let's go ahead and read it. Use the given statement to represent a claim and write its complement and state which is H naught and which is HA. So I'll have to go ahead and use my pen tool here. So this represents the claim. So you don't know what mu stands for. Is that mean of the population for a car or SAT scores? Here we just don't know. What the claim is, he says the population mean is greater than or equal to 624. That's what they are claiming. Remember, if it's greater than or equal to, as soon as you know it's an equal to sign, what do you think that is? That is your H. What is it? H naught or HA? H naught, because it has an equal to sign. So your next step is to write your alternative, which is your HA. Once you know which your H naught is, HA becomes very simple. How is that? It is again mu, the same, mean of the population. Opposite of greater than or equal to is simply less than the same number, 624. It has to be the exact same number. Everything stays the same except the signs, okay? So your step one should be taking a pen and paper and writing this down on your pen and paper, and then go back and plug in. I'm assuming you did write down your mean, your H naught and HA as well. So let me go ahead and check what the complement is. So this is my claim. The first one is my claim. The second one is its complement. So the complement is if it's greater than, the complement is less than. I'm going to go ahead and check. Very good. And remember, we just did it. What is my H naught? This is my H naught. So let's go ahead and see which could be my option. So my H naught is greater than or equal to. So not this one, not this one, not this one, not this one. Yeah, it could be this. It could be this one too, but look at my HA. Both of them cannot have equal to signs, so definitely not this one. H naught is greater than, the opposite is not equal to, so definitely not this one. When you look at this one, this is greater than, and this is also greater than, so not this. Not this, because greater than and equal to are not equal to. Do you see that? They're not opposites. So the only option I'm left with is option E. So be very careful when you check your options. And then check. You've seen an example. Let's go ahead and look at the next step into the process. Types of errors. So no matter what your hypothesis is, you always assume that your equality, which is your null hypothesis, is true. So what do I mean by that? Remember, when you start your hypothesis testing, you have your H naught and you have your HA, which is your alternative hypothesis, correct? In H naught and HA, remember H naught always has an equal to sign and HA does not have an equal to sign. It doesn't matter what your H naught and HA is. In your hypothesis testing, you start with assuming your null hypothesis is true. I want you all to look at the concept here. So what you have to do here is you assume your null hypothesis is true. You do all your math and you only end up with two options. Either what you assumed is true or what you assumed is false. You see how the science here works? So you always assume your null hypothesis is true. You do all your math and then you either prove your null hypothesis is true or your null hypothesis is false. That's all you have to do. What does that mean? If your null hypothesis, let me go ahead and change the color. If your null hypothesis is true, what does it mean about your alternative? Automatically it is false. Do you see that? If your null hypothesis is false, what does it mean about your alternative? Your alternative is true. Okay, it is slightly confusing, so you might want to rewind it, do it again, does not matter. But the way you start your hypothesis testing is always by assuming your null hypothesis is true. So you either have to prove it or disprove it. If the null hypothesis is true, by default, alternative is false. If null is false, By default, alternative is true. Okay, so now let's go ahead and see what the next part is. So when you perform a hypothesis test, one of the two decisions will be made. The decision one, you reject your null hypothesis. That means your null hypothesis is false. You fail to reject your null hypothesis. That means your null hypothesis is true. Okay, so only two cases. You reject, that means you're saying, oh, you know what? I assumed it's true, but I'm rejecting it. That means it's false. You fail to reject, that means you're accepting it. But in statistical terms, you say fail to reject. So when you say I'm failing to reject, you're accepting it. When do you accept it? When it is true. So it will get slightly tricky. So let me go back. You reject when it's false. You fail to reject when it's true. So you will not use the words true and false. You will say reject or fail to reject. Again, I repeat, reject or fail to reject. Remember, you are starting with assuming your null hypothesis is true. When you reject it, what does it mean? It is, right? False. When you fail to reject it, what does it mean? You're failing to reject. That means you're accepting it. So it is true. Okay, let's go ahead and see what is next. Okay, let's say you reject, let me go ahead and use my pen tool here again. Let's say your null hypothesis, remember what you start with, you always assume your null hypothesis is true. So this is what you assume, null hypothesis is true. Let's say, for instance, let's say your null hypothesis is true. Okay, so you don't reject it. That means you're accepting it. What does it mean? You made the right decision. Your null hypothesis is true, but you're not rejecting it. You made the right decision. But what if you reject it? You made a wrong decision. That means it's your type 1 error. So type 1 error occurs when your null hypothesis is actually true, but you are saying it's false and you're rejecting it. I repeat, your type 1 error occurs when your null hypothesis is actually true, but you're rejecting it because you think it's false. Now let's go ahead and look at type 2 error. Remember, you always assume your null hypothesis is true. But what if it's actually, you assumed it's true, but what if it's false? You are assuming it's true and it is false. So what should you do? You should reject it. When you reject it, that is a right decision. But what if you don't reject it? That is your type 2 error. Okay, so let me go ahead and show this to you again. Your null hypothesis, hold on one second here. So you assume your null hypothesis is true, right? But what if it's actually false? So when your null hypothesis is false and you reject it, that is very good. But when your null hypothesis is false and when you do not reject it, that's your type 2 error. So type 2 error occurs when null hypothesis is false and you do not reject it. So you do not reject it. The easiest way I like to remember my type 1 and type 2 errors. Type 1 is when my null hypothesis is true. My null hypothesis is true, right? And what do I do? What's my keyword? I reject. So HONR. What is my type 2? When null hypothesis is false. So when null hypothesis is false, what is true? Alternative is true. So I want you all to write this down. These are the keywords. Alternative is true. But what do? Do I reject or fail to reject? I fail to reject. Okay, that has to come up. I fail to reject. So the keywords are HO, reject. That means null hypothesis is true and I reject. Type 2 is HA, That means your alternative is true, but you failed to reject. Let's go ahead and take a look at a problem from your homework. Problem 10 and 11 are exactly the same. So let's go ahead and start with problem 11. These are the steps that I want you all to follow when you are doing your problems. So for a statement below, write the claim as a mathematical statement. This is very important. You'll have to write it down as a mathematical statement. You have to state your null and alternative hypothesis and which represents the claim. So I'm going to take you step by step. I want you all to have your pen and paper ready and be very attentive. So what I did is I went ahead and opened up a Paint document here so I can show you what I'm doing. So I will read the problem and write it down as I read. So I'm just going to pick a different color here. So it says an amusement park claims the mean daily attendance is 19,000. You always have to start with your claim. That is very important. It will say the word claim, C-L-A-I-M. Okay, so what are they claiming? They say the mean attendance is 19,000. Do you see what they're saying? That's what they're claiming, right? It's very clear. And this is my claim. This is my C. I'm just going to say CL. That's my claim. So once you have that, you know what your claim is. Your next step is to see if your claim is null or alternative. Let me go and take a look. Is my claim null or alternative? What is it? It has an equal to sign. So what do you think it is? When it has an equal to sign, blindly, it's my null hypothesis. Do you see that? Okay. Once I have my null hypothesis, what is your next step? Your next step is to write your alternative hypothesis. What do you think your alternative is? Mu, so this is also mu. If this is 19,000, this will also be 19,000, right? What changes? Only the sign changes. If this is equal to, what is the opposite? Not equal to. That's how you start. You should always see the word CL on your paper, H naught, HA. These two should be the same. These two should be the same. Only thing that's different should be the signs here. I'm going to use a different color. See if you can see it. Only these two signs should be different. Okay, now let's go ahead and finish this one here. So what does it say? Write the claim. What is my claim? My claim here is H naught mu equal to. Okay, that is my claim, and I check my answer. Excellent. And they're saying choose the null and alternative below. Okay, I'll go back here. It is equal to and not equal to. So see, I have two options. C is not equal to, mu is equal to. But keep in mind, only your null hypothesis should be equal to, not your alternative. So be very careful. Don't pick C. See how your null is not equal to? No, your null should be equal to. And then you check your answer. Very good. Now let's go ahead and see what they're saying. Identify which is your claim. Which is my claim? What did they say my claim is? My null hypothesis is my claim. Do you see that? My claim is my null hypothesis. So null hypothesis is my claim. Very good. What is your alternative? Oh, there you go. That's okay. That was the only question. Okay. But if they ask you what your alternative was, this is your alternative. Okay. Now let me go ahead and erase this so I can have ready for the second question here. Okay. A local chess club claims the length of time to play a game has a mean of less than 59 minutes. Write sentence describing type 1 and type 2 errors for hypothesis test for this claim. Every time they ask you type 1, type 2, it doesn't matter what they ask you. Let me go ahead and pick a pen here. It doesn't matter what they ask you. You always start with your claim. What is the chess club claiming. A local chess club claims the length of the time to play a game has a mean of less than 59 minutes. So has a mean of less than 59 minutes. This is my CL. I always start with my CL. Do you see what I just did? Okay. Now my second step is to see if this is my H naught or HA. What is this? This is my H. I don't have an equal to sign. So what is this? This is my HA. Everybody with me? Okay. Okay, once I have my HA, what is my next step? I need to have my HO. I always like to write my HO on top of HA because that's how they are in the options too, so I don't get confused. Same thing, this is mu, this is 59. What changes? Only the sign. If this is less than, let me undo it. If this is less than, what do you think this should be? Greater than or equal to. Remember, if there's no equal to sign, it's not your HO. Okay, so once you finish writing your claim, you finish writing your H naught, you finish writing your HA. Now for the keywords. Remember what we did in the previous PowerPoint. For your type 1 error, your keywords are H naught and reject. For type 2 error, what are your keywords? HA and fail to reject. So I'm going to keep this while we do the problem here, and I'm going to walk you through. Just going to move this just to the side so y'all can see. Type 1 error. So the first problem is type 1 error, right? So type 1, H naught, and reject. The type 1 error occurs if the actual mean length of time to play a game. Okay, so what is my H naught? What is my H naught here? Greater than or equal to. But let me go ahead and show you the easiest way. What do you do for type 1 error? What's your keyword? Your keyword is reject. So what do you do for type 1? Reject. What is the opposite? Type 2, what do you do? Fail to reject. Do you see that? Very good. The null hypothesis. What is your null hypothesis? Greater than or equal to. Null hypothesis is, where is greater than or equal to? Greater than or equal to. The null hypothesis is greater than or, where are you? Greater than or equal to. Remember, null hypothesis does not change. It's the same for type 1 or type 2. But for type 1, what has to be true? H naught. What is my H naught? Greater than or equal to. For type 2, what should be true? HA. What is my HA? Less than 59. So, what are you? Less than? Less than. Do you see that? So let's go ahead and read it. Type 1 error occurs if the actual mean length of the time to play the game, which is H naught, is greater than or equal to, when it's actually true, but what do? You reject it. Type 2 occurs when HA is true. What is HA? The mu is less than 59, but what do? You fail to reject. Okay?